We are going to solve problem 2 and we'll be considering ideas of this problem in APMO 2023. We'll be considering 4 ideas. This idea, sum of positive divisors, you should know this, 1 to Rn, sum of elements in a geometric sequence. A small example, this structure, which is useful also in SUMAC, Stanford Summer Camp telescoping product. And after solving this problem, you can try these 4 homeworks from AMC12, AIME1 2023, SUMAC Stanford Summer Camp 2022, and Promise Another Summer Camp, Prestigious Summer Camp 2022. And if you had question, feel free to send message to my WhatsApp number in the description. Okay, APMO 2023. For problem 2, we have an important idea that is useful also for other years, other exams, and for this problem of APMO, these problems are similar. AMC12, A2021, AIME1 2023, SUMAC for Stanford Summer Camp 2022, and Promise 2022. You can solve these problems as homework. Now let's try this problem. Problem 2. It says find all integers n satisfying n at least 2 and sigma of n over p of n minus 1 is n, in which sigma of n denotes the sum of all positive divisors of n. And p of n denotes the largest prime divisor of n. So let me tell you, formula of sigma of n is what you should memorize this. Also for product, for number of divisors, we have formula. But here we need only formula of sum of all positive divisors, sigma of n, it is equal to 1 plus its ideal 1 plus p1 squared to p1 to the k to the alpha 1 times 1 plus p2 squared to p2 to the alpha 2, 1 plus pk squared to pk alpha k. Now, next identity or idea that you should know is this 1 plus r squared to r to the n is equal to rn plus 1 minus 1 over r minus 1, or you can negate both numerator and denominator. Usually when r is less than 1, we use this between, for example, 0 and 1. When we use this one. When r is greater than 1, we use this. So we have these formulas that you should know. Now, idea 3, that is so much important. We want to use a small example, but a small example means what? One approach is that you consider n1, n2. Another approach is that you consider, for example, n is power of a prime, p1 or p1 alpha 1, then consider p1 alpha 1, p2 alpha 2. And like this, you can generalize. Consider a small example on number of primes and power of primes. This structure is so much useful. For example, for this one, this structure useful for this AMC problem, AIME problem, SUMAC problem, Promise problem. Now let's see what can we say. In this part, let's check n is p1 alpha 1. So sigma of n over maximum pn is largest prime divisor of n. So here we have only one prime, so it is p1 minus 1. It should be equal to n. So here we can say sigma of n is equal to n times p1 minus 1. Now we replace sigma n with p1 alpha 1, p1 alpha 1 times p1 minus 1. So, okay, so here we know sigma of p1 alpha 1 is what? By the formula, by idea 1, we know it is what? It is 1 plus p1 squared to p1 alpha 1. It is equal to p1 alpha 1, p1 minus And let me tell you something. Here it says n at least 2, so it has at least 1 prime. And alpha 1 is at least 1. Because if alpha 1 is 0, then n equal to 1. Now here we can reach contradiction because this one is multiple of p1. P1 divides this, but here p1 doesn't divide this part because the remainder is 1. So that's a contradiction. So if you have 1 prime, it doesn't work. Now let's consider 2 primes. P1 alpha 1, P2 alpha 2. Sigma of n, here you can say sigma of n over n. You should use exactly similar approach in this promise problem and in this AMC problem. We should write it like this. Like what? We want to say it is equal to, here without loss of generality, suppose P1 is less than P2, is P2 minus 1. Sigma n is what? Because n is P1 alpha 1, P2 alpha 2, it is 1 plus P1 to P1 alpha 1 times 1 plus P2 to P2 alpha 2. And for P1, n is what? P1 alpha 1, we write P1 alpha 1 for this one, and P2 alpha 2 for this one, okay? Is equal to P2 minus 1. Now, here we can divide, so P1 alpha 1 over P1 alpha 1 is 1, next one is 1 over P1, if you write in reverse order, 1 over this is 1 over P1 alpha 1. And next one is 1 plus 1 over P2 to 1 over P2 alpha 2 is equal to P2 minus 1. Now, we should use identity 2, this one. If you apply that, first bracket is what? 1. Let me write 1 minus 1 over P1, 1 minus 1 over P1 alpha 1 times 1 minus 1 over P2, here P1 alpha 1 plus P2, 1 minus 1 over P2 alpha 2 plus 1. It is equal to P2 minus 1 if you switch left hand side and right hand side. And we know it is less than. Here we can say it is less than 1 over this one. It is what? P1 minus 1 over P1 times 1 over P2 minus 1 over P2. So we can write P1 over P1 minus 1 times P2 over P2 minus 1. Now, here there are some primes, 2 primes. We know it can be P1, minimum P1 is at least 2, so 2 over 1, and these numbers, okay? So we can say it is less than what? 2 over 1, 3 over 2, 3 next prime, 4 over 3, 4 is not prime, 5 over 4, like these things, okay? We write, because P2 is greater than P1, we write all of them to P2, P2 minus 1, okay? You can say less than or equal, because maybe P1 is 2, P2 is 3. Under this case only it is equal, because for other cases, these values are greater than 1, because something over something minus 1. Now we can cancel these things like this. So we can call it telescoping product, idea 4. Idea 4, telescoping rule or telescoping product. Also we have telescoping sum. So it is less than or equal P2. Okay? Now we can say something. We can say something. As you can see here, we use lots of things and reached this one is less than 2. And we considered, okay, if for example we don't have 2 or 3, we can say what? We can say, for example, we can ignore some of them, okay? And we know this product is P2. Suppose, for example, so one way is if P1 2, P2 3. This, or we can say P2 is at least 5, okay? So we can say we don't have 3 or 2. Suppose, for example, if we don't have 3. Let's see. If we don't have 3, we can say what? Suppose we don't have 3. Then P2 minus 1 is less than or equal to 2 over 1 times 5 over 4. We write all of them again times P2 over P2 minus 1. And we know if we have 3 over 2, it is P2. So if we multiply by 2 over 3, here we have 2 over 3 P2. Okay, why? Because this part is exactly this one times 2/3 to cancel this. So it will be 2/3 P2. Now we can say what? We can say, let me erase P2, P2, 2/3. We can subtract, it will be 1/3 P2, and we can take this one to right hand side 1. So P2 is less than or equal to 3, that's a contradiction. If we don't have 2, again you can say P2 minus 1 is strictly, also we can say is strictly, because here, P2 minus 1, if we don't have 2, we can say, okay, 3 over 2 times 5 over 4 times P2 over P2 minus 1. And in this case, we can say what? If we multiply all of them, it will be P2. So if we want to reach this, we should multiply this by 1/2. So it's P2 over 2. And, let me tell you something. Here also, if you want to cancel all of them, we can add other numbers that are not prime. So 3 over 2, then we can write 3 for all of them, okay? All numbers until P2, not only primes. So let me correct also this one. 2 over 1, next one, 4 over 3. Now that's okay. Next step, we know if it is P2, then when we don't have 2, it is P2 over 2. So if we simplify, P2 over 2 is less than 1. So P2 is less than 2, again contradiction. Now we can say what? We can say P2 cannot be greater than equal 5, because if it is this, we don't have 2 or 3, then here we reach contradiction. So the only case is P1, 2, P2, 3. So we can rewrite this. We can say what? We can say it is 2 over 1, 3 over 2. So let's consider n is 2 to the alpha 1, 3 to the alpha 2. And we know 1 plus 2 plus 2 to the alpha 1 over 2 to the alpha 1 times 1 plus 3 times 3 to the alpha 2 over 3 to the alpha 2 is equal to what? Is equal to maximum prime minus 1, 2. 3 minus 1. Okay, because it is this one. P minus 1. Maximum prime minus 1. Now, here we can say, okay, so it is 2 to the alpha 1 plus 1 minus 1, 3 to the alpha 2 plus 1 minus 1 over 2. We multiply by 2 both sides. So 2 to the 1, 2 to the this. And 1 more 2, 2 to the alpha 1 plus 2, 3 to the alpha 2. Now we can say what? We can say this number is an odd number. Okay? So it should be what? It should be 3 to the alpha 2. Because here it's not multiple of 3. Again, this one is if 3 are relatively prime, so it should be 2 to the alpha 1 plus 2. Okay? Now, 2 to the alpha 1 plus 1 minus 1 is 3 to the alpha 2, and 3 to the alpha 2 plus 1 minus 1 is 2 to the alpha 1 plus 2. So we can say what from here? 3 to the alpha 2 plus 1 is 2 to the alpha 1 plus 2 plus 1. And if we replace it here, if we combine these two things, so if we multiply this by 3, 3 to the 2 alpha 1 plus 1 minus 1 is 3 to the alpha 2 plus 1. And 3 to the alpha 2 plus 1 is 2 to the alpha 1 plus 2 plus 1. Okay? Now let's simplify. If we simplify this, 3 times 2 to the alpha 1 plus 1 minus 3 is equal to 2 to the alpha 1 plus 2 plus 1. Now if you take this to left hand side, this to right hand side, it will be 3 times 2 to the alpha 1 plus 1 minus 2 to the alpha 1 plus 2 is equal to 4. So here we can factor from 2 to the alpha 1 plus 1. 2 to the alpha 1 plus 1, if we factor, it will be 3 minus 2. It's 4 is what? 1. So, because it is 2 squared, so alpha 1 plus 1 is 2. So alpha 1 is 1. First condition here. Because alpha 1 is 1, we can replace it here. 2 cubed plus 1, 8 plus 1, 9. 3 squared. So alpha 2 plus 1 is also 2. So alpha 2 is 1. Now we can say what? Because alpha 1, alpha 2 is 1, so n is equal to 2 to the alpha 1, 3 to the alpha 2 is 6. So one answer. We found one answer and 6. Now, again, we can use similar approach when we have 3 primes or k primes. For example, suppose n is p1 alpha 1, p2 alpha 2 to pk alpha k. So sigma n over n is what? Try this one first on your own. Okay, so for this one, we can say it is equal to, like for 2 primes, 1 over p1 to 1 over p1 alpha 1. Without loss of generality, we can consider p1 is less than p2 less than pk. So p2 to 1 plus. And we know that k is at least 3 because we consider 2 primes. p2 alpha 2 to 1 plus 1 over pk to 1 over pk alpha k. Now we know it is equal to what? Pk minus 1. You can write it is equal to 1 plus 1 minus p1 to 1 minus pk alpha k plus 1. Sorry, here 1 minus 1 over p1. Next one, 1 minus 1 over pk. It is less than 1 over this, 1 over 1 minus this, exactly like 2 primes. pk, so it is equal to p1 minus 1 to pk minus 1. Now we can say what? Because they are different primes, p1 to pk, we can say it is less than or equal. And because we have 3 primes, you can say 2 over 1 times 3 over 2 times 4 over 3 to pk over pk minus. Okay, if we write all of them, because all of them are greater than 1, we can conclude this. Now, if we cancel again, if we apply telescoping rule, it will be pk. Now, we know what? We know that we don't need to, 4 is not prime, so we don't have this. Okay, and we have other terms. So if you don't have this, you can cancel this 4 over 3. Instead of 4 over 3, we know this one was 4 over 3. So instead of 4 over 3, we write 1, and we multiply both sides by 3 over 4. Okay? So pk minus 1 is less than 3 over 4 times pk. Now that it is 1, we can say, okay, we can say less than or equal, because maybe our primes are 2, 3, 5. But because of these, it is strictly less than that. Now, we can say what? We can say, okay, it was 3 over 4. We can take this part to left hand side, this to right hand side, so it will be 1/4. pk less than 1. So pk is less than 4. But we know what? We know pk, we have 3 primes. pk is at least 5, and it cannot be less than 4, so contradiction. So we can conclude our only good number is n6, because when we have at least 3 primes, it's not possible. For 2 primes, only 6 possible. For 1 prime, we proved it's not possible. We used 1, 2, 3, 4 ideas for solving this problem, and you can solve these problems as this one as homework 1, this one as homework 2, this sumac problem as homework 3, this one as homework 4. If you had any question, feel free to send message to my WhatsApp number in the description.